I want to revisit that RGB color model because it's relevant to some of the things that we're going to talk about in this module and some of the things that we're going to be doing with images. Now, if you remember, each pixel in every single image has a color assigned to it. And that color uses at least three numbers to represent that color. And those three numbers represent the levels of red, green, and blue light in that pixel. 000 is black, 255, 255, 255 is pure white. And then we have 16,777,216 possible combinations. That's how many colors your screen can represent, which, interestingly enough, is still far less than the human eye can see. So it's limited. In other words, only 16 million, 17 million if we round up. But those colors all have a specific numeric equivalent to them. Now, we can also add a transparency number. So we might have an RGB A model with the A standing for alpha, alpha transparency. So in addition to the color of the pixel, we have how transparent is that pixel? In other words, how much does whatever's behind that pixel show through? And so that also ranges from 0% transparent to fully transparent. So 256 times 256 times 256. We can represent those colors in a three-dimensional way so that you can see how those colors are related to each other, and you can kind of get an idea of the map. Now, each of these cubes is only 6 by 6. And if you can imagine that it's not just the outside of this cube that's showing the colors, but the inside also. So there are maybe imaginary blocks inside this cube that have color. This is already a lot, and it's only 6 by 6. But if you can imagine this cube was 256 blocks in each direction, you can get an idea of all of those crazy different combinations. So every color you can probably imagine can be represented using those, and maybe some that you can't. So this is the white corner. So if this is one side of the cube, whatever you don't see on the other side might look like this. So as we go from full strength of all three colors, you can also see on one corner we have full strength red and 0% the other colors. If we have full strength red and full strength blue, then we get a color called magenta. Full strength blue and full strength green give us cyan, and then green and red at full strength give us yellow. So those are the kind of the points, and you can see those points are also represented on this side of the cube. It's just the full black and the full white that are on opposite sides. So that's just a way of thinking about color. But the big deal with color is those three channels, because every pixel in this image has a number. Could be 0, but it has a number that represents each of those three colors.